Hi, everyone. We'll get started. But thank you all for coming. I know the session is really late in the day. Conference is about to wrap up. Our brains are already overflowing with a whole bunch of new information. So it means a lot. This is my first time at One Summit, actually. And it has been amazing to get to learn from all of you through your talks and through conversations. And it's an honor to get to also share some of what I've been working on, what we've been working on at Merely AI with all of you. So with that, my name is Brian Hill. I work at Merely AI as a machine programming researcher and the CEO chief of staff. My background is mostly in statistics and artificial intelligence through my graduate work at Stanford University, where I had the privilege of doing research with Andrew Ng and Justin Goshlich, some of which we'll get to touch on today. And this is a 10-minute talk, so I'll just dive sort of straight into it. We are Merely AI, and that's also our website. There's a lot more on there that I can't cover in just 10 minutes about what we do. But we're a small Stanford startup, and our CEO is Justin Goshlich. He actually teaches at Stanford how to adapt artificial intelligence and machine learning methods specifically to improve the developer experience and to change the way that we really are interacting with code and code bases. And our goal is to revolutionize the way that we do software development. But we first sort of started to tackle code quality. We feel like based on personal experience and based on sort of some research on how developers spend their time, most of the time is spent just trying to understand code. Both code that you wrote 2 years ago and code that's written by others more recently. And so this is the area that we wanted to tackle with sort of our first projects, building AI and ML specifically focused on improving code quality. And third, thanks to our partnership with the Linux Foundation and with the Cloud Native Computing Foundation, all of our products are completely free for use on any open source software project. If you're an open source developer, feel free to let us know. We can get you set up. But we really want to give back to the community. I mean, we've been lucky enough to work with them and partner with them, and they've provided tons of insight into our projects. And also, our model is actually trained on a lot of open source software code permissively licensed. And so it's only natural to give back. And I originally had many more slides that had a lot more words and numbers. But I actually thought it could be fun. It's kind of late in the day. Let's do something with more colors and visuals. So I'm going to try to do a live demo of the main product. This is Merely Mentor. The model underlying the system is trained on over 1 trillion lines of open source software systems. And why we've done this is we want to learn what high quality code is and what low quality code is. And we've optimized it thanks to our chief engineer, Urs Muff, to be able to run at the scale of an entire millions of lines of code repository, analyze all of that code and identify interesting segments that are potentially lower quality, or at least code that we haven't seen in high quality open source software repositories. So how many of you have heard of OpenSSL? If you raise your hand. OK, that's great. I see most people. For those of you who haven't heard of it, some people consider it sort of the backbone of the internet, really. There's a lot of secure network protocols that are implemented through that library. And I've actually put it into Merely Mentor to be able to analyze it. So OpenSSL. What we can see here, my favorite part is always the graphs. There's the fun colors. We've analyzed this repository at 10 points, starting from its inception in 1998, I believe, all the way up to 2024. And this blue line, this is just the number of lines of code. We can see more recently it's maybe started growing more quickly. But then what our model can do is it can calculate a score on holistic code quality over the entire repository, using our model that's, again, trained on over 1 trillion lines of code. So here we can see how that score is changing over the history of the repository. We can see it's been mostly strong throughout its entire history. And then starting in 2016, maybe it started to experienced some changes that led to a decrease in what we would consider the code quality overall in that repository to be. And there's many components underlying this mentor score, but one of the largest ones are the amount of issues that we detect per 10,000 lines of code. So here we can see, yes, that makes sense. That also spiked up after 2016, which is leading to that decrease in the overall code quality that we're reporting for OpenSSL. Another thing I always like to look at is the contributors, which we also have over the lifetime of the project. So here we can see they were sort of almost corresponding with that jump in the issue. There's a lot of new contributors, a lot of development happening on the project, new commits, which is exciting. This is probably maybe a high growth phase for the project, but it's also possible that we've accumulated some technical debt in that development. And there's a few other things that Mentor can do. There's also summaries on sort of the overall trends in the repository that are picked up over this lifetime analysis. There's also the ability to sort of watch and see if you're interested in, oh, hey, the code quality score dropped by this much, I'd like to know. But one of my favorite things is to look at the actual issues for those of us who are also engineers. And we can see there's a lot of issues that Mentor sort of identified as potentially being instances of low quality code. But one that I was looking at earlier that was kind of fun is this one here. We really focus on the conditional expressions, since that's where we've, in our research, observed most bugs can tend to sit, or at least with a higher frequency than in regular code. Here we can see a fairly complex conditional expression, at least to me. Full disclosure, I am a more junior engineer, so potentially for those of you who've been working in the industry for a while, this makes complete sense immediately. But we see there's a few different conditionals being checked in this single conditional expression. And for those of us who also are trying to understand what's happening, we've read a description of what we think is happening. This is from our model. And we also provide a potential way of rewriting it. This is just one potential way. There's a lot of different ways we could do it. Our mindset is, again, code quality is of the highest priority. And if we make our code higher quality, if we make it more readable, everything else will sort of fall out. If the code is more readable, then it's easier for us to identify if it's incorrect. It's easier for us to identify if it's inefficient. It's easier for us to identify if there's a security vulnerability or something of that order. And so that's why our first priority is to make it more readable, and hopefully those other things will surface themselves. We know there's not just one way to write code. So we provided sort of 4 different options. And you can see they're doing it sort of differently each time. This one appears to be defining some intermediate variables, maybe some functions, breaking it down to make it less complex overall, and perhaps more digestible to somebody who's trying to understand the code and build on top of it. What's also interesting to me about this specific instance of code is that maybe you can notice already down here, there's another red box. This is the original code, and it looks like there's some fairly similar code a little bit further down. So potentially, we've also sort of found an instance of code being copy, pasted, slightly modified, which maybe we've all done at some point. But it could also make sense if we're focused on code quality to consider refactoring this into a function, a higher level of abstraction, since we're sort of leaving ourselves vulnerable to changing one of these instantiations when we want to have a change in behavior and forgetting to change the other one. And then we're incurring some amount of technical debt in that process. Looks like there's still a little more time. I also wanted to go in one other repository we've been having fun looking at, React Native. Last time I Googled it, used on over 1 billion devices globally. And here we can just look at the top code issue detected by the model. So pretty widespread. It may even be running on your phone at some point today. But this is the code flagged by our code quality model. And we can see a few different interesting things happening in this segment. Again, this is just some code that our model says it hasn't really seen before in high quality code instances. I can see some of you are trying to understand it right now. It looks like there's sort of a bitwise operation first, and then there's inside the conditional expression a ternary with variable assignment, and it's unclear if that variable is actually used later on in the conditional expression that's deciding whether or not the code below should execute, which is maybe somewhat unusual, somewhat challenging to, again, digest. And with that could be uncovering some other behavior that we don't necessarily expect. As always, sort of looking around one of the issues identified by Merley Mentor, there's usually other interesting things happening. One of my favorites, okay, I'll wrap it up really quickly, is here we can see this line, flags and 512 null and equal to current. This just evaluates to a true or false from my understanding, but it's actually executing code. So it's acting as a conditional expression, just through this logical operation, which is also interesting. But to go back here again, if you take away, I know I rushed through a lot of things. If you take away anything from this presentation, there's more information on our website. And yes, our mascot is our CEO's dog dressed as a wizard. I expected that question to come up. A small Stanford startup, focused on code quality. And if you're interested in code quality, if that's a priority to you, we're free for the open source community. I don't have a business card. But if you're interested in having it for free, that's a link to my LinkedIn. Feel free to take a picture. Feel free to scan it. Or just come up and talk to me. And we can get you set up with a permissive open source license. So thank you for the wonderful conference over the past 2 days. And I'll take any questions. Yeah?
You published the rankings and prospectus that you guys have there for public repositories on the website. See it?
The prospectus for?
The graphs that you're showing.
Yes, yeah, so we can set you up with a license. You can run Merley Mentor on any repository that you have access to. And you can get all of those same graphs, all of those same results, all of those same issues. Absolutely.
I can the general public just see what we're just looking at in terms of that analysis on OpenSSL?
Yeah, absolutely. Completely open to the public. You can run it on your computer, and again, it's optimized, so hopefully, if your laptop is reasonable, it should be able to run it just overnight. Yeah. Yeah? Are we? No, that's a great question. I think we're not quite at the point where we're executing the unit test to confirm that the proposed potential alternatives are actually completely functional or mimic the original behavior. We may get there someday. And I think we really have the most confidence in our model that can identify the interesting code segments and less confidence in the actual generations. We'd encourage you to still think a little bit before just like copy pasting them in. But I think I'll take any other additional questions out in the hallway. Thank you so much for coming out today. And again, take care, everyone. Great to meet you. Thank you.